Mark your own. Here we go. Who's my favorite student? Oh, good old Anne. Number 1 says, what is the definition of a force and what is the unit of force? Well, the unit of force is the Newton, or F equals what? I guess technically that means it's a kilogram, M, meter per second squared, A. That's what we used to write, and then we decided to name that a Newton after Sir Isaac Newton. There's a committee that decides these things. What's the definition of a force? What did you say? Force is a push or pull. I'll totally take that. I guess you could have said it's a mass times an acceleration. I would certainly have to accept that, the product of mass and acceleration. Anybody say anything else? It's an interaction at the quantum level when we're exchanging bosons. That's also true, but generally don't dive that deep. Okay? Number 2, what net force? What force? Net force. What force? Net force. There is going to be, and we're not going to be doing your test for a couple of weeks, but there will be a question on your test, probably the first written question. It'll involve something with the net force. So when I say net force, I can go straight to F equals ma. How many variables are there in that equation? 3. As far as I'm concerned, I can give you any 2, and Cole, you can get the third one by itself. You can get the A by itself using Scott's theorem. You can get the M by itself. Divide by A. That would also work. Anyways, this wants the net force, so I'm just going to straight plug and chug. M, 1200, A, 2,400 newtons. Is that right? 1 mark. Number 3 also wants the net force, so I started out writing down F equals ma, and then I paused. I said, well, they gave me the mass, but they didn't give me the acceleration. So even though this wants me to find the net force, I'm going to spend most of my time finding the acceleration. I drew a little line like this, and I said, okay, A equals question mark. I saw starting at rest. I saw a VF of 770 meters per second, which is pretty fast. Oh, and I saw a distance traveled of 1.5. I said, I can find an acceleration if you give me that data. I'm going to use VF squared equals VI squared plus 2AD. I'm going to use A equals, let's see, the VF squared would drop down like a domino. I would minus the VI squared, and I would divide by 2D. And this is important. I need to let you know, I'm not going to ask you any relativity stuff on this test because we're never going near the speed of light. But Cole, because F equals what? M. Anything that involves acceleration from a couple of units ago is still fair game and will be asked. It's going to be 770 squared minus 0 squared all over 2 times 1.5. Bracket 770 squared. Will minus 0 squared make a difference here at all? I skipped that. Divided by 2 times 1.5. And I got a little nervous at first. That's a huge acceleration. But then I looked at the actual numbers. Eric, 1.5 meters is about like this, maybe. You know, spread your arms out. That's roughly 1.5 meters. And we're going from 0 to 770, which I happen to know is twice the speed of sound in that distance. Yeah, that's going to be a pretty significant acceleration. So I actually said, that looks good. I wrote down 198000, but I stored it on my calculator. Because I said, I'm going to use this over here. It's going to end up being F equals M, 65. And I even wrote the word answer to say I'm writing using my answer button. I don't feel like writing all that out. So I went 65 times answer button. And I got a big number. I think I'm going to write it in scientific notation. Now, if you wrote out that whole thing, fine. I'm going to go 1.28 times 10 to the 1, 2, 3, 4, 5, 6, 7 newtons. If you got that, 3 out of 3. Otherwise, I would probably give you a half mark if I saw that, a half mark if you went 65 times whatever you got for the acceleration, and a half mark for that. Over on the right, I would give you a half mark if I saw that you would realize that we could find acceleration using that. I would give you a half mark for the numbers and a half mark for finding the acceleration successfully. Oh, forces come in. So the cannon applied that force, the artillery cannon applied that force to the shell. When that shell hits another object, it's going to apply a similar force. This is why artillery shells do so much damage, because that's a fat ton of force. That's a lot of force. Of course it's going to do damage. Oh, 65 kilograms, that's what? That's a fair bit of weight. That's about the mass of a small person. This is going to do some damage when it hits. For number 4, I went straight to Scott's theorem. I saw a net force and I went, okay, A equals F over M. It's going to be 12 divided by 1.2. Scott, what'd you get? You better get that one right, right? Uh-huh. 1 mark. Number 5. Average acceleration. I looked at the data and I said, you know what? I'm not using Scott's theorem. I'm going to go, T is 32. VF is 3.2 times 10 to the 4th. From rest, VI is 0. I said, I'm going to use A equals VF minus VI over T. It's going to be 3.2 times 10 to the 4th minus 0 all over 32. I can do this in my head. I can move that over by 1, which would move that over. Is it 1,000? Meters per second squared. That's a big acceleration. I can tell you this is not a manned spacecraft because that's around 100 Gs. What's the average net force? Oh, okay. Why did I say average net force? I suspect the force isn't constant because as you're burning rocket fuel, your mass might be changed. I don't know. So whenever I say average, it's my way of saying, look, if we had calculus, we could probably do this better, but it's probably a changing force. I'll hedge my bets. It's going to be... Are you taking the phone call? Okay. No problem. Average net force. It's going to be mass times acceleration, which is 1,000. I think I'm just going to do it in scientific notation. I think you'll get 4.5 times 10 to the 7th newtons. So a 4, a 5, and 6 zeros, if you wrote it out. Is that right? Okay. A net force. A what force? A net force. Now, it wants me to find a distance. So I said, okay. Well, I saw the good old from rest. VF equals 12. What else do I need if I want to find distance? I said, you know, I need to find that. Then I can go D equals VF squared minus VI squared all over 2A. So I walked over here and I said, I think I can use Scott's theorem because it says a what force? A net force. So I can go, the force is 1.6. The mass is 6.4. Did you get an acceleration of 0.25 meters per second squared? I think. And now I can walk over here and I can say, okay, 12 squared minus 0 squared all over 2 times 0.25. I should be able to do that in my head. 12 squared is 144. And 2 times 0.25 is 0.5. 244? No, sorry, 288. 288. Is that right? Okay. Meters. 2 out of 2 if you got that. Otherwise, I would probably go half mark for that. Half mark for that. I would give you a half mark if I saw that you'd realize we needed to find the acceleration, and a half mark for doing that successfully. B, time. I think I'm going to use VF minus VI over A. You could also do it with D equals VIT plus a half AT squared because VI is 0. So you could also go T equals the square root of 2 times D over A. You could probably use the one with the brackets in it for that matter, but I went with this one because it's the one I'm the best at rewriting because I did it so much. So I said it's going to be 12 minus 0 all over 0.25. 48, is that right? Yep. 2 marks. I guess here I would give you 1 mark for that, half mark for the numbers, half mark for the answer. How many marks is number 7 worth? How many true-false questions are there? 4? You know what? Half mark each. Makes sense? There are a book is sitting on a level desk. I just imagined my binder sitting in front of me. There are no forces acting on the book because it's not accelerating. True or false? False. What are the forces acting on it? Get the obvious one. Gravity. Oh, and there must be something else counteracting gravity. Okay, so I definitely would say I know there's at least gravity. The magnitude of the normal force between the book and the desk equals the magnitude of the gravitational force on the book. I think that's true. In our free body diagram, the forces are, I'm looking for a word that starts with the letter B, balanced. The fancy phrase for that is the net force is 0. Oh, the net force is 0. That's true. I just said that. Friction is what's holding the book on the desk. Whenever you give me a question involving friction, my go-to strategy is to reimagine the situation on perfect ice. If your desk was made out of ice, would the book still stay there? I think as long as the desk is level, yeah. I don't think friction is what's holding it on. So I think this is false. We're going to be doing the next 2 days looking at friction, by the way. Example 8, elevator questions. First thing I noticed is, what are the units next to that 588? Newtons. Is that a mass? If it was a mass, what would the units be? So the very first thing I did before I even jumped in is I said the mass is going to be 588 divided by 9.8. 588 divided by 9.8. I said the mass we're talking about here is 60 kilograms. Now that I had that, I was ready to deal with the question. Elevator is accelerating up. This is a job for a free body diagram. What are the forces acting on this person? We have gravity down. We're accelerating up. So the scale, which is the normal force pushing up through the person's feet. My equation here is normal force minus mg equals ma. As far as I'm concerned, Aleph, I can give you the acceleration like in this question and say get the normal force by itself. Is that okay, Fahim? I don't know why I called you by your last name. That was a little weird. Or I could give you the normal force and say get the A by itself. Scott's theorem, divide the whole thing by m. By the way, also I could give you the normal force, gravity A, and ask you to find the mass. We'll get there, but there's 2 m's. That's a bit trickier, but we will eventually do missing mass questions as well. Here, I think the normal force is going to be ma plus mg. It's going to be 60, not 588, times 1.2 plus 60, not 580. You know what? Actually, mg is 588. I could just put that in there and save myself some writing. Y'all get 660? Units, it's a force. Mallory, what if instead of saying the normal force, what if I asked what would the scale read in kilograms? How can I convert newtons to kilograms? Divide by 9.8, okay? That's sort of on your formula sheet in that when I told you weight is mg, I'm also saying m is weight divided by g. Okay. Elevator accelerates downwards. Now I got a little bit lazy and I said, maybe I can just imagine this free body diagram. If we're accelerating downwards, which arrow would be longer? More specific, in my free body diagram, which arrow would be longer? Which force? mg. Who would be winning? Same answer. Okay, so I didn't redo the free body diagram. I said it's going to be mg minus normal force equals ma. Swappy dance. The normal force has a negative in front of it. I don't like that. So what's going to happen is I'm going to get mg minus ma equals the normal force. The normal force is going to be mg 588 minus 60 times 2.25. And I got 453 newtons. Okay. By the way, if you didn't get these right, I would probably go half mark for that, half mark for getting the normal force by itself, half mark for the numbers, half mark for the answer. If you use the 588 as your mass, I would give you 1 out of 2 on each of these. What's the key phrase in part C? Constant velocity. So what does that mean? Your acceleration is exactly what? Which means the forces are, I'm looking for where that starts with letter B. You know what? The normal force is 588 newtons. It's got to be. Again, this is why Albert Einstein said there's no experiment in the universe that can tell the difference between constant velocity and at rest. Same answer. What if the elevator was accelerating downwards at 9.8 meters per second squared in free fall? What would the scale reading read? Zero. So for these two, it's going to be 2 marks, kind of an all or nothing. If you can give yourself a lovely score out of 23, if you need to lawyer with me, now is the time.